I'm a game changer. I'm a risk taker. I don't hide from the battle. The battle hides from me.
Hello judges, I'm WENDOLYN, and today I'll be sharing about my CoSpace experience. Before I begin, here is some information about myself. As I already introduced, I'm WENDOLYN, ID SG5005. And my RoboCup experience includes RoboCup on Stage 2019, International CoSpace Online 𝗘𝗄𝗁 Challenge 2020, and Virtual RoboCup Asia Pacific 𝗣𝗲𝙗𝗀 2020. And other robotics experience include National Robotics Competition NRC 2018 and 2019. So now, I'll move into the summary of the preliminary challenge. I am participating under the category of CoSpace Rescue FirstSteps U19, and the problem I investigated was to find the most effective way to maximize the points earned consistently. The methods I used were basically making use of as many RCAP software features as I could, and a lot of trial and error and comparison of strategies to select the best possible game strategy. The result of the method is as follows. The lowest score achieved was 1,875, and with improvements in the strategy, I managed to achieve an average of 2250 with a record of 2710. The conclusion from this is to try out various methods and selectively choose strategies and only adopt those that are effective. Now, I will be moving on to the analysis of the challenge. So the challenge mission was to earn the highest possible score by collecting and depositing objects. To tackle this mission, I broke it down into mini tasks, namely general movements, obstacle avoidance, trap avoidance, deposit, and collection. Once all the mini tasks have been successfully completed, the overall mission will be solved. I will now go into the breakdown of the AI algorithms and resources used. As for the AI algorithms, I'll be breaking them down into 5 different segments, namely basic movement, color sorting, square targeting, wall obstacle avoidance, and trap avoidance. So we'll first begin with basic movement. This function takes in speed and rotation parameters, where both parameters ranges from -1 to 1. For speed, -1 means maximum speed backwards and 1 means maximum speed forward. For rotation, -1 means maximum speed in anti-clockwise direction, and 1 means maximum speed in clockwise direction. Under this function, there is also another variable known as max speed, which determines the maximum speed that a robot will run at depending on its location or number of loaded objects. So in areas where there are no traps, or the robot has no loaded objects, it will run at full speed as there is no point avoiding traps. If the robot is in an area where there are traps and it has loaded objects, it will move slower at a speed of 85. Next is the color sorting function. First, the different possibilities of colors that can be detected are determined. The RGB values of the different colors are analyzed and split into different cases. The function checks the RGB values, determines what the robot is detecting, and returns an integer for that particular case. Integers returned are fed into the function in charge of the robot's actions to determine what actions the robot should carry out. Next is the square targeting function, which makes use of the coordinates on the map. The map is split into a 3x3 grid, where each square has a set of unique coordinates. The software's variable, position X and position Y, tells us the coordinates of the robot's current position, and with the coordinates of our target position, the horizontal and vertical distances can be calculated. Using those values, the A102 function can be used to calculate the angle the robot needs to travel at in order to reach its target position. This function is used to get to squares with specific colored objects or deposits to reduce time taken as compared to blind sweeping. Now I'll be moving on to wall obstacle avoidance. This function makes use of trigonometry to correct the left and right ultrasonic sensors from 45 degrees to 0 degrees, as originally they are tilted at a 45-degree angle. This function is used together with square targeting function mentioned previously to determine which rotation is more dominant. Lastly, we have trap avoidance. Trap avoidance works when any or both of the color sensors senses the warning zone. Should the loaded objects be more than 0, both of the wheels will move backwards, but one will move faster than the other, so the robot can safely turn and move away from the trap. Should loaded objects be 0, the robot will run over the trap as there is no need to avoid it. Next, I will be moving on to the implementation of the algorithms in the preliminary challenge. For the basic movement, it is first split by the number of loaded objects. If loaded objects equals to 0, max speed will be at 100 as there is no need to avoid traps. Similarly, if loaded objects is not equal to 0, there will be a further split based on the position of the robot. If it is not near a trap, it moves at a speed of 100, and if it is, it moves at 85. Next is the color sorting function. The colors are first split according to their R values, followed by their B and G values, until it is narrowed down to only one possible case. Once the correct case has been determined, an integer assigned to the case will be returned. Lastly, we have square targeting, which is first split up by the time remaining on the clock. When there is more than 15 seconds left, there will be two different cases, where loaded objects equals to 6 and where loaded objects is not equals to 6. When it is equal to 6, it will go to the deposit that is easiest to access from its current position. However, if loaded objects is not equal to 6, it will continue collecting objects based on the deposit number. Based on the deposit number, they will go to different squares to collect red and cyan, but the same square for black, as there is only one area that spawns black. As for when there's less than 15 seconds left, if there are less than 3 loaded objects on the robot, it heads to 1-1 to collect all objects. But if it's more than or equals to 3 objects, it heads to the deposit that is most accessible to. To see how all of this works, here's a demo of the preliminary run at 2 times speed. Now we'll be moving on to the debugging process. Generally, the robot performed quite well. There were some small issues with depositing, but it was fixed with more stringent criteria for depositing, like ensuring that both color sensor senses the exact RGB values of the deposit in order to carry out the deposit function. Next, the conclusion. So 2 different methods were tried out for square targeting. The first method includes 2 collection routes, one for odd and one for even, while the second method involves 3 separate routes, one for odd, one for even excluding the 4th deposit, and one for the 4th deposit. Method 2 was slightly more effective as it reduces the rate of depletion for the red objects, thus saving enough time for the robot to make an extra deposit in time. Overall, I am quite satisfied with the result, but if I were to solve the task again, I would consider the different combinations of objects that can be collected, as some color objects are in greater numbers than others. Lastly, the learning experience. From the experience, I learned to strategize effectively, mostly through the process of trial and error. And to the other participants, I would say that they should just try any strategy that they can think of and keep testing and improving it. Thank you for your kind attention. I hope you enjoy my presentation.